Hello, everybody. Welcome to my talk about hardware-based data transmission from the device to the cloud. My name is Dirk Rosenau, and I work for FP Inovolabs in Berlin, Germany, not far away from the center that is presented here in the slide. And before entering into the session, please allow me to show you at least one slide explaining what FP does and its business. FP as a holding provides digital services starting from paper-based to electronic mail and supporting service handling, and combined with a secure payment and secure data transfer. So FP belongs to the top 3 market leaders in that franking business. FP Inovolabs itself is that part of the FP holding forming most of the R&D team. So Inovolabs designs, implements and brings to production a suite of smart devices, including hardware and firmware. But we also implement software-only products like PC software, web services, or cryptographic front-end servers, or even business servers for maintaining the lifecycle of the devices, including their device management. In regards to payment, our smart devices transfer up to 1.5 billion US dollars per year, which is part of the revenue of our customers. So what does that have to do with IoT? Well, it is the fact that we manage more than 200,000 smart devices, each of which uses a number of sensors and actuators. And why are we interested in the IoT? Because we can offer our knowledge to partners, and as you know, IoT is a partner business. And we can enter into new markets and finally generate new products. And of course, that is of interest for us all. Okay, so here's the agenda for this session. Let me go through it very quickly. Number one, you are probably listening to this session here because you want to find out how to increase security within your IoT projects. For those who need some arguments to motivate others in your organization, we will share some thoughts on that. Number two, we will look on a simple example of a typical architecture that connects a device to an IT infrastructure. And based on that, we will identify some common tasks that we all know about. And when talking about these challenges, we will identify potential topics where to add more security and where you could add more trust to such an architecture. And number three is, after that, I will explain a new approach and you will learn about the benefits it brings in protecting your data using a hardware security model. Although we are not Apple, there's one more thing to show and complete the connection between FP and this Amazon Web Services. And this is that we'd like to explain you a little bit our secure IoT gateways, and which we also presented it on the Amazon Web Summit. And finally, of course, I've prepared a summary for you. Okay, in this section, I'd like to motivate you why you should care about security if this is not yet the case. And I'd like to start with a magazine, the Forbes magazine, an American magazine about economics. And they published an interesting article where they say that IoT manufacturers and their customers don't care about the security of up to 8.4 billion internet connected devices currently connected to the internet. Well, if this is true, we need to discuss a few slides first, and all of the following slides look very similar. You will find a typical statement that could be argued in an organization, but there are aspects to be considered seriously. The first one deals with the content type of your data you are managing. If you are dealing with data that at a first glance does not seem to be private or sensitive, however, you should remember that you could potentially lose its integrity. So, for example, the order or sequence is very important, and if this becomes incorrect, Or if you double a piece, or if you drop some data in the middle, you may lose the value of that data. Here's another statement. The business is not of interest to attackers. Well, attacks are sometimes driven by teenagers or ex-employees. And you could also suffer from a collateral damage or from a global attack. And don't neglect the fact that it might be an intellectual challenge to an attacker to attack your business. So that's of interest. Here's another one. It's the state-of-the-art buzzword. State-of-the-art software may refer to operating systems or frameworks or libraries. And popular software, state-of-the-art software, is typically more interesting and challenging for attackers than specific solutions. But be careful if you think you will be protected if you implement it on your own and deviate from the standards. This, you may be then affected by other risks. Well, strong encryption is definitely good, as long as you have strong protection on your sensitive data, especially the key material. Otherwise, a decryption of your data is just a function call away. So if you have access to the key material, you could just use the reverse function, and then here you are. And that's the final slide for that topic. And if you claim that you never had an incident, it might be very, very difficult to provide evidence that this statement is really true. So how can we be sure? In this slide, a summary of the costs of cybercrime is given. The damage by cyber attacks has been skyrocketing in the recent years. So this image shows only numbers up to the fiscal year 2015, so it's a little bit older. But if you browse the internet, the numbers that you will find are much, much larger. So if you can't read this slide, the costs in 2015 in the US were about 15.42 billion US dollars, while the sum of these 7 countries evaluates to 45 billion US dollars. And as I said, if you browse the internet, you will find recent values of the worldwide costs, which are 10 times higher, about 400 to 450 billion US dollars. And last and least, definitely, there is an estimation out in the internet that says that in the year 2021, we will reach probably up to 6 trillion US dollars worldwide costs. Well, don't ask me how they estimate that. I have no idea, but if this is true, it's definitely a topic for us all, because it affects companies in many ways, and only a few are given here on the list. It may affect your profit, reputation, and you may also have problems due to lawsuits or other legal investigations. So why do even the best companies fail? Well, probably because security is difficult. I have arranged a few acronyms here, and we will all together have to deal with those when designing secure devices or even applications. So if you are familiar with these terms or know how to use them and probably have undergone a security approval by an accredited laboratory, then we have a lot common. And we believe that maintaining data integrity is one of the keys to prevent hacking. So, however, let's jump into the next topic. So let's browse through a typical example. And I prepared a slide here, and you may assume we will talk about this as a simple architecture. So the IoT device is a piece of hardware in this example, and for providing this, and the device is collected to different sensor types and extracts the data from the sensors. And of course, when doing that, It stores the data locally. Probably there's also some pre-processing for filtering or whatever your domain requires. So for providing this data to the cloud service provider, you can follow a well-documented API and choose your authentication method. For example, you can use the X509 certificate management, and those will be those certificates you can generate using a console, or even more sophisticated or even better interfaces from your cloud service provider. And there are possibilities to do that. More individual configuration can be done in the cloud. So, for instance, of course, you can connect a dashboard to it and view your data then later in the dashboard. But basically, the key material that you use is locally stored in your IoT device, while the other key material that is required to connect to the cloud is managed by your IT service provider. Okay, so back on the IoT device, there's a bunch of open source libraries, or you may have contractors or even other vendors that provide you with libraries to run almost on all embedded systems to set up your mutual TLS session between the device and the cloud. So this TLS channel provides you a secure and confidential tunnel to provide your application payload from the device to the cloud. TLS stands for the Transport Layer Security, which is typically used in your HTTPS internet connections if you use a browser, for instance. And mutually here means that both parties can authenticate each other. That is to say that not only the device knows it is connected with the correct server, but also the server knows exactly which device it is talking to. You can compare this to your online banking accounts. So you connect to your server, and you do this with a browser. Your browser identifies to you by showing this green safe symbol in your URL, while you also need to authenticate to your server using your credentials, which is typically something like a account number or user ID and your password. So within this secure TLS session, your device could use application protocols like MQTT or messages, which use messages to transport the necessary payload. But there are others out there, and it depends on your connection and domain what you decide to use. To implement such a case, you automatically need to care about the relevant topics, like we did when I explained this. It's the authentication, identities and their roles, services, data storage, and the transport protocols. So you have to decide about the necessary firmware and algorithms to realize this showcase. Depending on your specific domain, this may vary, and that's fine. Okay, but now I have a few questions, and that is probably worth to think about. If you are not controlling the access to your device, how can you be sure that it is your device that's showing up data in your dashboard? Are your devices only reporting to that dashboard and not to someone else? Are your devices really unique? Probably they are duplicates because someone has set up a clone that might be by accident, but also intentionally. So how can you also add evidence to your data in your IoT device, such that, for example, you can grant a correct sequence number, or that you can add another proof of payment, for instance, on individual events? So the bottom line here is, how can you provide your customers with an even higher level of trust in these devices if they are operated without continuously being monitored or operated within a secure area? So look at the users on the left. So they have access to your IoT device, and they could fiddle around if you operate your IoT device in a hostile hostile environment. So you need to protect the data that's stored on your device before you set up this channel and upload the data to your cloud service provider. So bottom line, and this is a summary of all the results you probably have learned here in this slide, your security relevant data items or critical security parameters need to be protected from unauthorized modification or substitution. Otherwise, your business can be attacked. Your data can be cloned and duplicated by accident or intentionally. Identities of your IoT device are not certain. And if you do not use firmware that follows the recent security rules and algorithms, this may result in loss of trust, insufficient security, and definitely increase the vulnerability to attack. Okay, so not all risks are predictable, right? But many can be anticipated. And I'm sure that the vendors of the presented products weren't expecting the bad publicity shown here. And the messages have been taken from several BBC articles that popped up in, I think it was March this year. So with some effort, you can learn from products used in regulated markets. And if you think of banking industry or personal identity cards, they have a lot of regulated stuff and specification, and we all have at least some trust in these products. So FP Inovolabs itself, we learned a lot in the postal business, which is also a regulated market. And we can tell you that there are solutions available to secure your products and gain more customer trust and increase sales. And of course, also to promote your products in unregulated markets. And we'd like to explain you a little bit in our business what we are using, and we can also offer that for others. But I'm quite convinced that this is of interest at least for you. And the topic I'm talking about is a hardware-based security module. I will show you some of the regulations in our business. And this is our situation. So we have about 200,000 devices that are connected to our infrastructure, and they connect on a regular basis. The devices are located at our customer site, and we don't control how they operate them, and we even don't know what they do to them. So they are operated in a hostile environment. However, each of the devices is equipped with a hardware security module. So the hardware security module is a cryptographic module that acts like a safe or vault, protecting its content. In our case, that is money and other sensitive data like the identities that I was talking about, and of course the key material, especially the private keys, but also public certificates. Okay, so the regulating authorities, and for example, those are typically federal agencies, they demand that we follow the national laws, of course, and the standards. So the NIST, and NIST stands for the National Institute of Standards and Technologies. So the NIST is the important institute in the North American market. And they publish and maintain such standards. Some are called Federal Information Processing Standards, and this is where the term FIPS comes from. All standards are typically given a number, and some popular security standards you may have heard about are the Secure Hash Standard, which is FIPS 180-4. And the -4, for instance, just stands for the 4th generation. There is another important one that you may have heard about. This is the Advanced Encryption Standard. It's the AES. It's a type of algorithm, cryptographic algorithm. And it stands, the standard itself is FIPS 197. But the most important one for us in this session is FIPS 140-2. And this is the standard on cryptographic modules. So companies have to comply to those standards if they want their products being used by federal agencies. And this is not only required in the North American market, because other industries and countries adopt those standards, like I said, the banking and the postal business as well in other countries like Europe. So now that we are aware of these standards for cryptographic modules, there are 2 more validation programs to assure vendors are correctly applying them. While the CMVP, the System Validation Program for Modules, they take care that your module is correctly implemented and tested. There's another program, it's the Algorithm Validation Program. And this makes sure that the algorithms, the cryptographic algorithms that you are using have been tested and verified against their standards. Okay, so there are also NIST accredited test laboratories, and there are about 20 out in the world. So those labs do the operational testing. And with operational testing, that means that they take your module, typically it's a production grade module, and they run a specific suite of tests. So they also do the source code review, and they do documentation review, and well, believe me, there is a lot of documentation required to do this testing. And yeah, and if there's also hardware involved, which is the case for hardware security modules, then they also do some physical testing. And we will come to that a little bit later. So it's probably interesting to have a little bit a look on the different levels of FIPS 140-2. So FIPS 140 has 4 levels of security, which increase from 1 to 4. While level 1 provides basic security, for example, there are a bunch of libraries on Microsoft and Linux operating systems that are level 1 validated, and you can use these libraries and be sure that these libraries have been tested by some laboratories, that they are really using correct algorithms and they have been tested. So you have a minimum of security. So I would recommend you, if you are implementing software solutions, you at least take care to pick one of those libraries. For another level of trust, you could increase to level 2. And this typically requires you to add a hardware module, because you need to add tamper-evident coatings, seals, or even PIC-resistant locks. That tamper evidence means that if someone tries to tamper or drill into your module, there should be an evidence that this occurred. So you could also use seals on covers, because that would also be then broken if someone would open your device. Besides this hardware stuff, you need at least to implement role-based authentication to verify that a user is authorized to assume that specific role and perform a set of services. If you add some more security to it, you would come to level 3, and this, for instance, adds tamper detection and response to covers and doors. So it's even much harder to manipulate your module, because it will respond. It will first detect that it was tampered and then respond by, for instance, zeroizing the key material in that module. So on top of that, you also need to move from the role-based authentication to the identity-based authentication, such that you really know who in person or on behalf of a person is running a set of services in a specific role. And then you also have stronger requirements for entering and output key material, just to mention that also. And level 4 is the highest level. It's very difficult, and it's probably also expensive to realize. And it requires an envelope of protection around the entire module. It requires you to implement environmental failure testing and protection. And this is basically in the areas of temperature and power supplies. So you need to make sure that if you need to define your temperature ranges and power ranges and verify during testing that if you leave these ranges, your module should not output or run any service by accident. So the best way you can do that is to monitor these areas, which would be tamper protection, and then shut down your module. So the overall rating for level is almost the lowest rating that was received for all requirements. So just to give you an example, FP's hardware security modules are overall level 3 validated modules, but we also include the environmental failure testing and protection part of it. However, because we do not achieve all of the requirements for level 4, we still remain a overall level 3 device. Okay, so this is probably one more slide. Based on the specification, NIST has generated a full set of derived test requirements, so-called DTRs. The testing lab will take this set and compile a subset that is specific to your module and level that you want to achieve. So you need to have available a production-grade version of your module for testing, and you need to support the lab in running the tests. For example, some tests require you to manipulate the data and thus form bad cases to verify the device handles them correctly, like simulating defects or attacks. So the tests of great difficulties are typically the physical testing. Self-testing is involved as well, so your module needs to run self-tests, which are conditional during the operation as well as power-up. And the random number generation as well as the key management stuff is very sophisticated and difficult to achieve. The initial version of FIPS was issued in 1995. Currently, we have the version 140-2 that was issued in 2001, but NIST also publishes additional implementation guidelines and standards that also apply. These are typically updated twice a year, and there are other approved security functions that all come into the play, and you need to approve your module also to this kind of requirement. If you look on the NIST website, you will find a bunch of modules that have been validated since the 1995. There are probably out more than 3,000 modules or even validated, revalidated modules. And typically, there are some sections where you can cluster them. So there are typically kernels and toolkits out there, which I mentioned already, typically level 1 software modules. But you also have a bunch of routers, VPN concentrators, accelerators, coprocessors, or even PC or smart tokens. Like if you think of your USB stick, you could add security to it to make sure that you cannot fiddle around and need to enter a password first before unencrypting all the data on that stick. And of course, and that's interesting, there is a bunch of modules out from the postal business, also called postal security devices. This is part of our business. Okay, I have 2 more slides, but I will just briefly go through them because I just compiled a list of advantages, and you can later on download this presentation from our website, but also probably from the Amazon Web Services. So I've highlighted 2 things here. That's the topic unique identity, and it allows you to exactly identify your device. So it's not possible to simply duplicate the data that you have because it's stored and protected in that particular device. Another topic is the strong protection. The hardware security modules protect your critical security parameters from being disclosed. You remember probably, as I said, the description, the decryption is easy if you have access to the key. So on this slide, I highlighted also two things, and I think that linking a business service with a cryptographic function can provide trust to your business model. So with services here, I mean the functions that your IoT device provides. So for instance, if you are generating timestamps or take images, or if you are reporting temperature events, or store fingerprints or anything other, if you link or combine these functions within your HSM using a cryptographic operation, you can add more trust, regardless whether it's confidentiality or integrity. So this opens a whole new world, and I would say that hardware can be offered as a service. And then there's another one. It's the fact that part of your products have been validated by an independent accredited testing laboratory and should provide you and your customers a higher level of trust. So you may use this also to promote your products. And now there's one more thing, and that's the IoT gateways using hardware security modules. What we did in the AWS summit this year in Berlin is that we designed a generic secure IoT gateway. And based on the existing hardware of our smart devices, we linked that with a multi-purpose sensor input device, and we used some CAN open techniques, but could be also some different buses. And of course, we provided the gateway with a unique identity by using our hardware security module. We took that and demonstrated that on the AWS summit. And the HSM was initially used to provide additional integrity to the data retrieved from the sensors, but could also be used to add additional confidentiality to specific data items. And we made use of the Amazon Web Services to connect the gateway to the cloud. On the next slide, we'll show you how we started the cryptographic scheme and how we can extend this by the hardware security module, which is already in place in the gateway. Okay, in this picture, the FP Secure Gateway is a piece of hardware that is located on the left side on the slide. And on the right side, you see the Amazon Cloud. I will introduce you to a simple process you can use to set up mutual authentication between a device and an Amazon Web Services. And in this picture, rectangles mark certificates. A certificate always includes the public key and an electronic signature from the issuer of that certificate. And certificates are issued by certification authorities, abbreviated CAs, like VeriSign is one of the biggest. So in this example, you can see VeriSign has a self-signed certificate. They have signed the Amazon Web Services root CA, and the root from Amazon has signed a gateway service, a gateway certificate. And in this picture, you also see another key that is the private key. Keys that are not enclosed inside the certificate are the private portions of it in my example here. And they, of course, need to be kept secure. But Amazon has their own secure techniques, like using hardware security modules, but also sitting in secure areas. But this is not the topic for today's talk. We will concentrate on your device side. The Amazon Web Service console can be used to receive key material required for the TLS session. The key material can be stored locally, and you can use that for your transport session. So in this example, you generate the key material on the Amazon Web Services and export the relevant portions of it to your gateway or IoT device. Once you have set up this situation, you can use the key material and set up a mutual authentication. What you can see here is basically our proof of concept or showcase that we presented. And As you can see, the keys can be used to authenticate in a mutual way because the gateway knows the Amazon Web Service root, so it's possible to authenticate Amazon, while Amazon will receive the IoT certificate, and because it was signed by Amazon Web Service root, they will have this trust to also authenticate the client. Okay, so let's go one step further. In this slide, we make use of an HSM, but this required a little bit a different approach. While AWS also supports generating your own key material and registration of your own certificate authority, and this can be used in the following way. So we still have the Amazon Web Services key material on the right, and we will need the Amazon Web Service root CA being stored on the left in our device as well. But of course, now it is stored inside of the hardware security module, as you can see by the safe symbol or board symbol. What's new in that case is that we operate our own data center. So the FP root CA signs a FP IoT data center. This is shown here. We operate our own FP IoT data center to, and the reason is that we manufacture our hardware security modules. And during this manufacturing process of the hardware security modules, the IoT device key pair is generated. So this, of course, needs to be signed, and it will be signed by the FP IoT data center. Now, the final step that needs to be undertaken is that we register our FP IoT data center to the Amazon Web Services cloud. Once this is done, we have a very similar situation to what we had the slide before. So it's still possible that the device authenticates the Amazon Web Services, and that's basically because we have the Amazon Web Services root CA stored inside of the module, and the other side of the mutual authentication is based on the fact that if we run a mutual authentication with our IoT device certificate or key material, it's possible that the Amazon Web Service Gateway is able to verify that because it was signed by the FP IoT data center, which has been registered to the Amazon Web Services. So there is a level of trust, and we can communicate using this mutual authentication. Okay, so there are no more risks, as you can see, because all the key material that was generated for your secure gateway or IoT device is stored inside of the module. So you achieve the level of trust given by your hardware security module. It's not possible to clone the device. The secure parameters are stored inside and protected from unauthorized substitution or modification. Okay, so final thing is to go through a summary. So we all have to deal with this security when it comes to transmission from devices to the cloud. FP has a specific solution that adds additional protection to your IoT devices. And it is an already proven and FIPS 140-2 certified hardware security module. You can use this to protect your critical security parameters, even in a hostile environment. And hardware-based security is, of course, not required by everyone. But as you may have learned in the earlier slides, it allows you to provide additional security and trust, as an independent accredited laboratory has validated the product. It allows you to combine services in your business with cryptographic primitives and thus generates a whole world of new business models. You may use those features also to promote your business models in unregulated markets, and you learn that from the regulated markets. Okay, so First of all, many thanks for listening to this talk. And you should probably be able to evaluate your risks on your own, and you know best your security requirements of your products. If you have questions, you can contact us on the Inovolabs website. You will also find a presentation for download. And if you contact us and get in touch with us by email or phone, we can also start a bilateral discussion on your topics and potentially may help you. So many thanks for listening to this talk. So probably if you have some questions, I'll try to answer them. Okay, let me go through the list here. So one of the questions is, what could be the form factor of the HSM? Well, in our business model, the hardware security module is required to support a lifetime of more than 8 to 10 years. So we typically need some performance factors in there, and we need to support a business model where you can take this type of credentials out of a complex system and move it to a different type of target. So such that if you have some repair stuff to be undertaken or some maintenance, you can take this identities, but be careful, you cannot clone it, but you can take this and then take this out and then run some maintenance process and re-plug it in again. So this is basically the form factor of the HSM in its physics. And in our business model, there are also some performance factors required. So typically we are operating in a range of, this was the question also, we are operating in a range of a few milliseconds per signatures, for instance, or I've forgotten the exact values for encryption and decryption, but if you're interested, you can provide us an email and we can compile some detailed answers on that. Okay, what else do we have? Can it be a small SIM card? Well, basically that's true. There are solutions out there in the field where a SIM card can be used as a secure anchor or token, and you can use it, authenticate to your SIM card and use it for encryption, decryption, or whatever. But typically these smart cards, they do not allow to provide you, for instance, with a real-time clock or other, let's say, functions that you could combine and link to these crypto primitives. So if you, like I said, if you would like to add some additional business function to it, like we do with a payment, you need to add specific firmware on these cards, which is a specific thing. And if you're not able to do that, it's probably also better to use a different type of module, which allows you to upgrade and downgrade or modify firmware or add new services when you think you are entering new business. Are there any? Oh, here's one more. Have you thought in securing constraint services, for instance, microcontrollers communicating over low power networks? Yes, definitely. As you can see, we have mounted an antenna to our FP Secure Gateway. And of course, this is an interesting thing. So at the moment, we are thinking of different types of communication networks like low power Bluetooth, as well as WLAN. But basically, that depends on the vendor and the specific domain. So we are basically focusing at the moment on different vendors that implement, how do you say, big big machines, and typically it's hard in their environment to use over-the-air communication. Any more question that I can answer? And please, if you have questions that are specific to your business and you don't want to put them here on the table, you may still contact us and we can start a bilateral conversation. Okay. Thank you very much for your attention.